Welcome back to Basic Biostatistics 2, to the Santa Claus Super Study and to the second part of the model number 5, ANOVA. In this class, I would like to show you how to make repeated measures ANOVA, and in case that the continuous variable does not follow a normal distribution, how to use a non-parametric test, in this case the Friedman's test, to analyze the data. As an example, I will give you, we're going to try to see whether there's a statistically significant difference in diastolic blood pressure of month number 1, 2 and 3. We also would like to know whether this difference is different for dwarfs who smoke and those who don't smoke, and whether smoking affects the diastolic blood pressure of these 3 months. We find repeated measures ANOVA and analyze, generally in the models where we can find out the ANOVA test, and this time we select repeated measures. The first window which opens asks us how many levels does the factor 1 has. Factor 1 refers to the dependent variable diastolic blood pressure. In that case, we have 3 measurements of diastolic blood pressure. That's why we write 3. And we click on add, and now we have defined that factor number 1 consists of 3 measurements. The next step will be clicking on define, and we see the usual window we have in SPSS with all the variables to select from on the left side, and on the right side we have the different windows where we can add the variables. First we'd like to move the variables of diastolic blood pressure months 1, 2 and 3 to the upper right window, and this we achieve by clicking first on diastolic blood pressure month 1, we click on the arrow, we click on diastolic blood pressure month 2, we click on the arrow, we click on diastolic blood pressure number 3, and we click on the arrow, and now we have told the system that the factors are diastolic blood pressure 1, diastolic blood pressure 2 and diastolic blood pressure 3. As we would like to add to the model smoking and to see whether the tendency, if there is any, was different for non-smokers and smokers, we select the smoking status variable, which is categorical, and we move it into the between subject factors window. If we click on model, before analyzing, we're going to check the different buttons we have. In model, you will see that the system already defined the full factorial system, which means that we don't have to do anything. We click on continue. On the plots, if you're interested, you could have separate lines for smoking of a factor, as we did basically in the previous model. Let me select, for instance, factor 1 as horizontal axis, and smoking we click on separate lines, and we click on add to show you one example of a plot. Click on continue. We could have post hoc test in case that we have a categorical variable that has more than 2 categories. If, as in our case, smoking has only 2 categories, we don't need post hoc tests, because if there's a difference in the tendency between smoking, it means that there's a difference between non-smoking and smokers. So we don't have 3 categories, only 2, and this is why we don't need post hoc tests. In case we would have chosen body mass index categorical, which has 3 different categories, we could select a post hoc test, for instance LSD or Turkey. In this case, we click on continue, and we still have options. In options, what we're interested in are homogeneity tests. We select homogeneity tests, and we're interested, at least by now, for now, in descriptive statistics. We select those 2, we click on continue, and now we are ready to analyze the data and to run the system and the analysis. We click on OK, and as usual our output windows opens with a lot of different tables and pictures. Let us have a look at the different tables. First of all, it tells us the factor 1 consists of diastolic blood pressure 1, 2 and 3. We have a between subject factors, which is the categorical variable, which is smoking status 1 for as non-smoker, 2 as smoker, 30 observation each. The next statistic is descriptive, as we have selected it, and we see that the diastolic blood pressure of month 1 for non-smokers and the smokers, diastolic blood pressure of month 2 for the non-smokers and smokers, and the same for diastolic blood pressure month 3. What we could do, basically, we could have a look if there's a tendency in the mean values of the diastolic blood pressures. If you have a look at the non-smokers, they start with 97.93, continue month 2 to about 96, and end up in 92. A clear decreasing tendency and mean value of diastolic blood pressure. The same actually for the smokers, 98, 96, and 92. So there seems to be a tendency, and there seems to be a tendency of decreasing diastolic blood pressure for smokers and non-smokers. But we would like to know if this tendency is statistically significant. First of all, the program runs a multivariate test, and this multivariate test we already see that the factor 1, which is diastolic blood pressure, is statistically significant from the other factors during the 3 measurements. And we see from factor 1 and smoking that there's no interaction. This means that the changes of diastolic blood pressure is the same for smokers and non-smokers. So smoking does not affect the decrease in diastolic blood pressure because the p-value is bigger than 0.05. If we go further down, we have a Mohs test of sphericity. This is something similar like the homogeneity variance test. Basically, if the test is statistically significant, there's no homogeneity variances, or what we call there's no sphericity, and we have to interpret the data of sphericity not assumed. In this case, the value is 0.000. It's so low that we can't even calculate the p-value, so we consider that this test result is statistically significant. And we go to the next table, where we have basically the analysis for different factor and for the interaction term. We can see that we have a line sphericity assumed. In case of the Mohs test, would be statistically non-significant. In this case, it is statistically significant, which means that we can choose any of the 3 other tests, for instance Greenhouse-Geiser, Freund-Feld, or lower bound tests. Let us choose the first one, the Greenhouse-Geiser, and we check the p-value, and the p-value is smaller than 0.05. This means that there is a statistically significant difference in the 3 measurements of diastolic blood pressure of month 1, 2, and 3. We can also see of the Greenhouse-Geiser test of the interaction term that there's no interaction between smoking and diastolic blood pressure. The p-value is 0.321, which is bigger than 0.05. If you go further down, we're still interested if there's a difference in the smokers or not smokers. We have a test of within subject contrast, which is basically the same as it was in the previous table. And then we have a Levens test of equality of the variances. The conditions or assumptions as well for repeated measures ANOVA is that there's no difference in the variances of the variables. And in all of these cases, we see that diastolic blood pressure month 1, of month 2 and month 3, the p-value is bigger than 0.05, so the assumptions are valid and we have no problems with the design of repeated measures ANOVA. In case that one of these variables or p-values would be smaller than 0.05, we would have to need a non-parametric test. Finally, we go to a table test between subjects effect, where we have the effect of smoking. This basically tells us, was there a difference in diastolic blood pressure and tendency between smokers and non-smokers. The p-value is bigger than 0.05 because it's 0.919. This means that the decrease in diastolic blood pressure is the same for smoking and non-smoking groups. Finally, you can see the profile plots of the non-smokers and smokers. It's basically parallel, and you see the lines don't cross. So we have the same effect of the decrease in diastolic blood pressure for smokers and non-smokers. In this case, as we assume that Santa Claus had an intervention, this means that the intervention was significant and it worked for both for smokers and non-smokers. Good. In the second part, what do we do if the continuous variable is not normally distributed or if the variances are not equal? In that case, we're going to use a non-parametric test. The non-parametric test for repeat measures ANOVA is the Friedman's test. That's how it's called. We find it in non-parametric tests and here under related samples. We click on related samples and we go to fields, and I had already pre-selected the blood pressure values, but in that case we select systolic blood pressure month 1, systolic blood pressure month 2, and systolic blood pressure month 3, because we know that the systolic blood pressure variables are not following a normal distribution. Then we go to settings. On settings, we click on customize tests and we see where we can find the Friedman's two-way ANOVA by ranks tests. We have it on the right lower corner. We select the tests and we are ready to run the analysis. Usually non-parametric tests are much simpler. We usually just get one simple window with the test results. As you see now in the output file that we have the distribution of systolic blood pressure months 1, 2 and 3 are the same. That's the null hypothesis. It tells us which test has been selected, the Friedman's two-way analysis of variance by ranks, and the p-value. The p-value is statistically significant as it's less than 0.05, which means we reject the null hypothesis. This means that there was a statistically significant change in systolic blood pressure month 1, 2 and 3. This means the intervention of Santa Claus was successful. Nevertheless, you need to check and explore whether there was an increase or decrease in systolic blood pressure, because the non-parametric test doesn't give us the descriptive statistics in this case. Good, this is a short introduction into repeated measures ANOVA to get an idea how to use this test and what's the related non-parametric test tool. Now you're going to be ready for the quiz and the exercises. I hope you use your time well, you plan your time well, and that you submit the exercise and the quiz in time. Good luck with the tasks and see you in module number 6.